Cisco Certified Network Associate Day 48. Welcome back everyone, I'm Imran Rafai, your trainer for this entire series. Today we're going to talk about Multiarea Ospf, and this is still IP version 4, right? So without wasting much time, let's get straight into today's class. Before we go ahead, I would like to thank our sponsors, Skillshare, which is an online community for learning. They have expert classes on design and technology. Have you ever thought of designing your own app and making some money out of it? If you have, then you must follow this video, which I think is the best, and he takes you from being an absolute beginner to putting your app on the App Store. And to add to that, our friends at Skillshare has been extremely kind to give us an exclusive link. If you use that link to sign up, you get 2 months of premium subscription for free. And this is only for the first 500 people who register with the link. So don't waste time. Click on that link in the description below. Today we're going to look at 2.4 again, continuing from our last video. But we will be looking at Multiarea Ospf today. So Multiarea Ospf for IP version 4 is what we're going to look at in this video. So the topology that we're going to work on today is we will have 7 routers. 6 of them would be working on Ospf, and the 7th router, that is the router here, this is, I just wanted to show you. So when you have multi-area, basically what we learned before, all the videos that we learned before this video, we learned on single area OSPF. That means all the SPF worked on the same area. Now we will work on multi-area. So these routers, that is router 6 and router 1, would be under area 45. Router 5 would be area 12. So these are single area router and they are internal routers to this area. Now this router, that is router 4 and router 2, they are ABR, area border routers, ABR, right? They are area border routers. That's what router 4 and router 2 is. What that means is they are routers which connect your non-backbone area. Area 0 is backbone. So the router that connects non-backbone area routers, or rather area, to the backbone area, that router is known as the ABR, the area border router, or any router that is in 2 areas is known as an ABR. This router, now this router, if you see, this is RIP, right? So any router that sits at the edge of the OSPF network, so when it is doing let's say for instance in your organization you have a case where you have some devices running on RIP or EIGRP, another routing protocol other than OSPF. Maybe it's an acquisition, you've taken over that company and now they're running EIGRP or RIP, and then now you have always been working on OSPF. What do? You can't just overnight move all of them to OSPF, even though that's what you would want to do over a period of time, but intermediately you need to do something, right? You need to work with those computers or with those systems. How do you do that? We do with something called as redistribution. So normally what would happen is you would take all the routes that's on OSPF and redistribute it to RIP, and whatever routes that's there in RIP would be redistributed to OSPF. Now this is called redistribution and it is not part of your of your CCNA. So we will not be discussing that. I'm just going to I've listed it here just to show you what happens. And if you have to work with another routing protocol, what do you need to do? You need to redistribute that. So you need to redistribute OSPF route to RIP and RIP routes to OSPF, and that is redistribution. Now redistribution, or this router that stays at the edge of OSPF, is known as ASBR. ASBR, which is nothing but Autonomous System Boundary Router, and this is called boundary router because it sits on the boundary of OSPF, right? So it's an autonomous system. That whole OSPF protocol is the autonomous system, and this stays at the boundary of OSPF, right? So that's why it's called boundary router. So these are all connected directly. So you have point-to-point networks connected. So how I've done is router 6 to router 2. 10.1 is common for all the networks. This is how I've designed this. And the third octet, this is router 2 to router 6. So the smallest number first and bigger number. So 2 and 6, so 26 and .0/24. Router 1 and 2, so it has to be router third octet is 12. Between 1 and 6, third octet is 16. Between 3 octets, so it is 2, 3, 4. So it's in ascending order, 2, 3, 4. Third octet. This is 3 and 7, so network 37. 4 and 5, network 45, right? Now, this network is a network that's, because it is not connecting to another router, it's just connected to one router. So I have kept it 20 because it's router 2, 20. And this is router 5, so this is kept 50. The difference between this network 50 and network 20 is network 20 is not going to participate in OSPF, right? And network 50 will participate in OSPF, but I'm going to make this into something we will learn called passive network, right? So we will look at that in a while. So we'll go straight into packet tracer, and then we will try to configure. As we configure, we'll try to learn different technologies. All right, so today we're going to look at day 44's packet tracer. This is a topology that we are going to work on. If you want to follow along, please feel free to click on the description, and the link for this download is going to be on our description. So click there and download it, and then you can follow with us. While you're there, don't forget to click on the like button on our video, and of course subscribe and hit that bell icon so that you will be notified whenever we add a new video. So we're not going to look at redistribution, so I have not put RIP. So we're only working in OSPF, and we're going to work OSPF in multi-area. So in blue, this is OSPF area 45. Yellow is OSPF area 0, which is the backbone area. Green is OSPF area 12, which is another area in OSPF. Router 1 and router 6 are internal routers to area 45, and router 5 is internal router to area 12. Router 2 and router 4 are ABRs, area border routers, because they are area border router. This network, and we discussed this network is different, and this network is passive. We will look at it in a while. So let's start with router 6. Okay. So since it is interior, it's an interior internal router to area 45. The configuration is exactly what we did in the last 3 videos. So I'm going to quickly go through that. Configure terminal, router OSPF 1, network. Okay. Now, we did this in the last video. If I want to enable OSPF in one command, I can do 10.1.0.0 0.0.255.255 area. Which area is this? This is area 45, right? If I hit enter, what happens is, what would happen when you do this? Cisco iOS would look at the running config, and it will look at all the interfaces with the IP address 10.1, right? So if you look at the wildcard mask, it says only match the first 2 octets, the third octet and the fourth octet. You don't have to match. So any IP address, right? If you look at all the interfaces, any interfaces that has IP address with the first 2 octet as 10.1, it would say enable OSPF on that for area 45. Now you can verify that by showing putting this command, that show IP OSPF interface. Now if I hit enter, it will show, okay, that OSPF is running on 2 interfaces, that is fast Ethernet 0/0 and serial interface 0/3/0, which are these 2 interfaces. So this internet IP address is 10.1.16.6, which is this, and 10.1.26.6, which is this, right? Now you can look at what it's doing. It's on area 45. It's a broadcast network. The state is in DR. Priority is 1. The interface designated router is 10.1.26.6. Interface is 10.1.16.6. And hello timer is 0, dead is 40, and all that interface. At the moment, there's no neighbor. That's why it says neighbor count is 0. In your serial interface, you would see that the network is, again, it's doing area 45 OSPF. Point to point. Of course, if it's a point to point network, there's no election, so priority is 0. No DR or no BDR for sure, because it is point-to-point network. And of course, there is no neighbor because we still haven't enabled OSPF in any of the routers around. We can confirm that. Show IP OSPF neighbor, and we see the neighbor table is empty, which is what is expected. Let's go to router 1 and do the same command. So enable configure terminal router OSPF. Now, we did a mistake in one of our last videos where we said process, right? The first video when I explained, and I apologize for that. Just to prove that it doesn't need to match, I'm going to give OSPF router 10. So router OSPF 10, now this process ID is 10. The router in router 6, the process ID is 1, and yet they would form neighbors. So how do we enable for both the networks? It's the same command, network 10.1.0.0.0.255.255 area 45. I do this. OSPF it should be enabled on both the interfaces. Show IP OSPF interface, and of course it is confirmed by that status message there, which says it has changed from loading to full, right? Gigabit Ethernet and serial interface. So these two interfaces are running on OSPF 45. This is gigabit because this is 2911 router. Router 6 was 2811 router. So don't worry about that. So 10.1.16.1 area 45. This is BDR. Obviously it will be BDR because it got a smaller router ID. Other one is a higher router ID, and this is lower router ID. It would, even if both of them came together, this would still be BDR, and that would be DR. So designated router, bracket BDR and DR's IP address and network router IDs are given here. Hello timer is due in 1 second. So every 10 seconds there is a hello that goes between these two. Adjacent router, it is adjacent with the neighbor 10.1.26.6, right? Again, the serial interface, point to point, we discussed this, the cost is 64 and all that interface that we discussed. We can do show IP OSPF neighbor. So this will confirm that the neighbor is happening through gigabit Ethernet, which is this interface. All right, now we will get into router 2, right? So router 2, the difference between router 2 and router 1 and 1.6, which we already did, is router 2 is an ABR. That means it needs to work on 2 areas. Now let's do the same thing. Configure terminal router OSPF 1. Now we can enable OSPF just like how we did in router 1 and router 6. We can say network 10.1.0.0.0.255.255 area. Now what do I give? Because it's working in multiple areas. How do I configure this? If I give area 0, what it would do is it would look at the interface command or running command and look at all the interfaces which has IP address 10.1 in the first 2 octets, and it will enable OSPF to run in area whatever that we give here. That's not what we want. We want only these serial interfaces to do area 45, only this fast Ethernet interface to do area 0, right? So what we could do, I mean, we've done this before, we could do something called 10.1.127.255. Now what happens? It says first 2 octet is same. For all 3, the first 2 octets are same. The difference is in the 3rd octet, where in area 45 it is 26 and 12, and area 0 is 234. Now one glance I can say that by using 1 bit, I can differentiate the two. By using this wildcard mask of 127, for people who know, it would be 0 for the first 2 octet and for the first bit of the 3rd octet, right? So in this, if you convert 0 to binary, the first bit of the 3rd octet is going to be 0. So it's going to say that 10.1 and the first bit should be 0. Now, if the IP address is 234, if you know binary math, 234 in the 3rd octet, the first bit will be 1. So that will not match for this interface. This command will only match for these two serial interface, and of course, because this one is in the IP address is 10.1.20.0, this one will also come into this area. So I'm not going to do that because I don't want this interface to be in Ospf at all, right? So I'm going to do another method. It's 10.1.26. So let's do this. 10.1.26.2 0.0.0.0 area 45. This is, you're saying very specific that any network or any interface that has an IP address 10.1.26.2 0.0.0 area 45, it should go into area 45. Hit enter. We can check that do show IP Ospf interface, and we see that serial 0/3/1, that is this interface, has gone into Ospf, which is what we were expecting, and that's in area 45. That's brilliant. Now, next is 10.1.12.2, that also has to go into area 45. The difference is this now. So this interface, 10.1.234.2, that's this interface, needs to go into area 0. The command is exactly the same. Only thing is we change the last part. So we can do that same here. 10.1.234.2 0.0.0.0 area 0. And now we are doing a multi-area Ospf where one interface is in area 0, the other two interfaces are in area 45. So that's area. So if you do show IP Ospf interface, we see that Ospf is running on 3 interfaces now. That's serial 0/3/1, 0/3/0. Both of them are area 45. And Fast Ethernet 0/0 is running on area 0, and it's a broadcast network. We know what is where configured. Let's do routing protocol. Show IP route. Okay, because the only network now, Ospf is running on this network, these two networks, and this network. The only network that this router 2 did not know is the 16 network, and that 16 network is learned via Ospf, and it is got now this is another thing with Ospf. Ospf can do load balancing, only equal cost load balancing, right? So from router 2's perspective, this is cost 64, this is also cost 64. So to reach this network, it has equal cost. So 64 and plus 1, which is 65, right? Which is obviously, this is no fast Ethernet, so that is 1. So 64 plus 1, 65 to reach this network. That's why it says 10.1.6 is 110 is admin distance. Admin distance is Ospf, admin distance is 110. That's the default. And the cost is 65. So it says equal cost to reach that network. I have 2 paths, both of them are equal paths. So whenever Ospf you have 2 networks with equal path, the routing table will have both those networks, which means that there is load balancing. So that's load balancing that is going to happen using this network. So any traffic that's going to that network is going to be load balanced on both these interfaces simultaneously. So that's load balancing. So it has learned what it has to do. One critical thing that you need to know is this network 10.1.20.0 is in the routing table for router 2. These devices, let's go to this device. This device, now technically this device does not know about 20 because it's not directly connected, right? Will the routing table have that network in Ospf? Okay, let's see that. Let me expand this a little bit. And we see that it has learned 1.12, which is this network, which it is not connected to, which is expected, what it should learn. And then it has learned 1.234 again, which is something it should learn. And you can see that there is this IA, which is inter area. We can look at here. IA, where is IA? Okay, it's here. IA, OSPF inter area. That means this network is coming from a different area. It's not from the same area, area 45. It's coming from an area other than 45, which is area 0. It's coming from area 0, and it's inter area OSPF route. So that's that. But yeah, did it learn 1.20? 1.20 was there in router 2, but it did not run a 1.20 because 1.20 is not participating in OSPF, right? It is there, but is not participating in OSPF. All right, now let's do router 4. Now router 4 also is the same thing. We have done this. It's again going to be multi-area, so we can do the same thing here. Enable configure terminal router OSPF1 network 10.1.45.4 0.0.0.0 area 12, and the other network is it is 0. This is 234, and that's area 0. We can go here, show IP OSPF interface, and we can see that OSPF is running on 2 interfaces, which is what we're expecting. Serial interface is on area 12, and fast Ethernet is on area 0. Now this is the common mistake, right? So always be sure once you configure OSPF multi-area, make sure your areas are correct according to your design on paper. You might have a design on paper, but when you configured it, you're not maybe putting it correctly. So that's a classic mistake that everybody does, and even I have done that, so nothing to worry about. If you've done that, just take it as a learning lesson and then proceed from there. Make sure your areas are matching according to your design. Next, we're going to come here. Okay. Now, the difference between this router 2's 1.20 network, 10.1.20.0 network, and 10.1.50 network is 50 network is participating in OSPF. So this is participating in OSPF, but this is not participating. So obviously, if it is not participating in OSPF, this network will obviously not get hello messages. So every 10 seconds, router 2 will not send hello out on this interface because obviously it is not participating in OSPF. So even if you put, if at all, I say I connect OSPF router into switch 3, and enable OSPF, it will not become enabled with router 2 because router 2 is not even advertising anything on this. No, there's no hello messages. It's not participating in OSPF, nothing there. But if we configure OSPF, let's say I configure OSPF here. Let's do the same thing. So let's do what we did. Enable configure terminal router OSPF1 network 10.1.0.0 0.0.255.255 area 12, right? If I do this, okay, sorry, this one, area 12, okay. Now, what happened? So, show IP OSPF interface, right? OSPF is running on both the interfaces, that is interface fast Ethernet 0/0 and serial, and they're running on OSPF area 12, which is what we expected. Now, let's say in your design, okay, now what happens? Let's go back here. Will this IP, now I've done the routing protocol, routing table on router 6. Now, router 6 has learned 1.45, which is this interface, and 1.50, which is this interface, and 1.234, which is this interface. So it's learned this interface, and this interface on OSPF, which is what is expected of it to do. But there is a problem. Now let's assume in router 5, you know that interface fast Ethernet 0/0, that is 10.1.50.0 network, you know there is no chance that you would ever connect a OSPF network. So it's the edge of your network, and you know that you would never, or at least for the moment, you don't have any OSPF routers going to be there. So there's no reason why this device, now at the moment, because it's participating in OSPF, it would be sending hello packets every 10 seconds because it's configured to do that. Now there are two problems with that. One, it's using unnecessary bandwidth. It's going to send a hello packet to devices like a computer, which would not even look at that packet. Take that and say, I don't know what you're talking about, and it's going to throw it off, right? Because obviously it's not doing OSPF. Second problem is, now once from the switchboard, you will have this socket running into a wall socket somewhere. There could be somebody like the bad guy. The bad guy would want to jeopardize your network, would want to bring your network down. All he has to do is configure an OSPF router, right? It's very easy. If you use packet tracers, you can look at every, even let's say, for instance, if those parameters are not matching, but it's very easy on a computer to look at those parameters, configure your router to match those parameters, right? And what if he connects an OSPF router with all fake routes, right? It could just give you some fake routes. And your router is obviously going to believe that if you give higher priorities, and if it's if it believes that it's going to be much shorter distance to reach to 10.1.26, and it says, okay, send me all the traffic, so that's going to bring your entire network down. So typically, administrator, you will have to block hello packet going out on interfaces where you will not have a router. Right. Another way to mitigate that is by having authentication. You can also have authentication. Like, for instance, if you have enabled in this network, let's say there are some computers also connected here. But obviously, because these three routers have to be neighbors, it will have to send hello packet. So if at all any computer is connected here, that is also going to look into your hello packets, and it could form neighborship if it knows how to spoof to be a router. To avoid that is why you use authentication. So you can use authentication where the hello message has to authenticate with a password before it starts doing neighborship. But that's secondary. We don't have to worry about authentication for CCNA, but we need to look at another interface called as passive interface. So passive interface, like, that's another concept. So passive interface is an interface that is part of OSPF, but it will not form neighborship on that interface. So all you have to do is go here, configure terminal, router OSPF 1, passive interface, fast Ethernet, or is it gigabit? I think it's gigabit. Was it gigabit? No, fast Ethernet. So fast Ethernet 0/0. Now, how do we know? So now if you've done this, what will happen is now router 5 will not send. This network is still in OSPF. We can verify that by going here and putting this. We can still see that 50.0 network is there. It's advertising those networks into OSPF, but it is not getting any hello packets on that interface. So we can look at that, show IP OSPF interface, right? We can see that hello is due in 005, and here it says no hellos because it's a passive interface, right? So there's no hello going on fast Ethernet because it's a passive interface, but here hello is due, and you know. So this is how you know if an interface is passive. So if you've only given this output in your exam and ask which is a passive interface, you know this fast Ethernet 0/0 is a passive interface because there is no hello going there. Another way to look at, obviously, is by running command. You can look at the running command, and then you will see that this interface is a passive interface. Now, there are two ways you can do passive interface. Passive interface is one, you enable OSPF on the network. Let's say if you have 20 networks and there's only one passive interface that you need to have. So you would use that command, which we used here, to enable OSPF. So you would, this command, you put one global command, and you can enable OSPF in all those networks. And then go back to router Ospf and just give whichever interface that you want to be passive. Another way to do that is, let's say you have 20 interfaces, and then 5 of them you want to be routed and 10 of them you want to be passive. So what you could do is you could say passive default. So you can go here, config router Ospf 1 passive interface default. When I say passive interface default, that means by default all the interfaces are passive. Only interfaces that you enable to be, advertising or sending hello messages into, those are the interfaces. So you have to manually then go and enable hello packets to go. So you're manually going and saying no passive interface. So these are 2 ways. Either you can say everybody's default passive or everybody's default not passive, and then do whatever is required. So I think we have touched on all the topics that you had to touch to understand different concepts of multi-area Ospf. So thank you for watching. Don't forget to click on the link for Skillshare and take advantage of the 2 months free premium offer that is given to the first 100 people. So don't waste any time. Click on that, register yourself, and get access to 2 months of premium access to Skillshare. And there are numerous videos in multiple domains and multiple technologies. So take advantage of that. Thank you so much. We will see you back very, very soon. Bye-bye.